Natural selection is the phenomenon first proposed by Darwin as a mechanism of evolution. Within this theory, adaptive traits appear over time, becoming more and more frequent within a population because the individuals with that trait have an advantage that allows them to survive or reproduce. This is known as descent with modification. These adaptive traits that allow for particular individuals within a species to have more offspring are deemed most fit. This is not, however, the only force that acts upon species. After natural selection, the next hurdle in the evolution of species is sexual selection. According to the University of Berkeley, sexual selection acts on an organism's ability to obtain or successfully copulate with a mate. This is the concept that sexual processes select traits to continue in a species, as opposed to being about individual organisms selecting sexual mates. Which survivors of natural selection are able to attract and keep a mate in order to reproduce affects how future generations will attract and mate with partners as well. A species that sets a perfect example of this process is the peafowl. Peacocks are famous for their striking plumage, both because of its size and fan shape, and its rich hues of green and blue. These iridescent feathers aren't found on all peafowl, however, just the males. Peacocks use their eye-catching tails to catch the eyes of peahens, which have a simple brown coloration. The health of each peacock is reflected in his plumage, specifically the length of the tail, often referred to as a train, and the number of tail eye spots the bird has. Correlated data has demonstrated that the peacocks with a large number of tail eye spots and a high rate of mating behavioral displays had low levels of circulating heterophils and a better health status. Heterophils are a form of white blood cell found within avian biology. The higher the levels of circulating heterophils within a bird's bloodstream, the more activated the animal's immune system. This indicates an individual more prone to infection, and thus a more sickly bird. Peahen sexual preferences are behaviors themselves supported by genetic predispositions. With all likelihood, the females who were attracted to and mated with peacocks with less eye spots and smaller tails produced weaker offspring. Those offspring would have been less successful, and natural selection would weed them out from there, leaving peahens that look for more impressive trains as a majority within the population. These indicators demonstrate to females which potential peacock partner is the fittest, with the best potential genes. Both the tails and the mating displays performed by males involving them are products of sexual selection within the peafowl species. One study concluded that over 50% of mating success was hinged upon feminine preference and the tail eye spots of the males who were attempting to mate with them. These findings were expanded upon in 1996, specifically defining the sexual fitness of peafowl as a result of the combined effects of male behavior and active female choice based on phenotypic traits. Still, these tails aren't without their downsides. These resplendent tails make it harder for peacocks to hide from and run from predators. Since peacocks make easy prey, the question is raised, how are peafowl not extinct? The answer to this question lies in the fact that peahens find younger and healthier peacocks to be more attractive mates. Because peafowl breed early, they have to survive significantly less time before reproducing. This leads to descent from peafowl that is less shaped by survival benefits and more shaped by which qualities are chosen by the females, effectively giving more power to sexual selection rather than natural selection in the shaping of the species. The mating displays and behaviors are a product of thousands of years of sexual selection. Sexual selection acts upon every species, gradually changing how genes are passed on through the generations. The tails of peacocks represent a particularly choice example of this force in the evolutionary realm.